Good evening, everyone. We need to start because we have a lot to cover tonight. So if people can start taking their seats and wrapping up conversations.
Lots of seats up here.
Yeah, there's plenty of seating still available. Hello, thank you all for coming. Welcome to the State of the Sawkill Forum. It's great to see you all here tonight. For those of you who don't know me, my name is Caroline Clocker, and I am the Environment and Energy Program Leader at Cornell Cooperative Extension, Dutchess County. I will be facilitating tonight's program, and I'm also joined tonight by my colleague Michelle Gluck, who will be helping out as well. Before we begin this evening, I'd like to acknowledge some key people who are in the room and joining us tonight. Pavan Naidu. Excellent. Pavan is here representing Assemblywoman Dee Dee Barrett's office. Thank you so much for coming tonight. Robert McKeon, Red Hook Town Supervisor, is here tonight. And Harry Colgan. Harry, can you raise your hand?
Hello, everybody.
Harry is also, he's on the town board of Red Hook. So thank you. It's great to have some municipal representatives and state representatives in the room this evening to hear all of this important information that we're going to be sharing. Tonight's program is a culmination of over 2 years of work by the Sawkill watershed community that many of you have been participants in. And this work has been funded by a grant from the New York State Department of Environmental Conservation Hudson River Estuary Program. The mission of the Sawkill watershed community is to protect the Sawkill watershed and its ecological, recreational, and historic resources through hands-on science, education, and advocacy. In addition to the work that you will be hearing about tonight, the Watershed Group organizes monthly meetings to educate the community about watershed-related topics and encourage conversations on how to protect the watershed and address watershed-related concerns and issues. If you would like to learn more about the Watershed Group and get more information about upcoming events, please be sure to have your email address added to our email list. And you can, as you signed in, there was a little box that you could check off where you signed in for if you want to be added to our email list if you're not already on there. So if you haven't already and you would like those updates, please make sure you check that off before you leave this evening. You can also learn more by taking a look at the Sawkill Watershed website, which is on our brochure, which hopefully you got a copy of when you entered, and if not, please be sure you grab one on your way out. Quite a bit of data and information has been collected by the watershed community and its partners over the past 2 years. Far too much to share in just one evening event. So the Sawkill Watershed Community Leadership Team decided to focus tonight's forum around 5 questions that the community members posed to the group as it was beginning in its infancy stages. And these questions have provided guidance to the direction of the group's work over the past few years. So these are the questions. So tonight you're going to hear more about bacteria and sewage contamination, nutrients and if they are a problem in the Sawkill, road salt application and its impacts on water quality, mitigating flood risks in our watershed, and then the connections between water quality, the watershed, and the safety of our drinking water. So we plan on covering quite a bit tonight. Before though we begin and start jumping into those presentations, I just wanted to acknowledge and thank the members of the Sawkill Watershed Community Leadership Team for all of their hard work in organizing tonight's event, as well as being a driving force behind a lot of that work that you're going to hear about tonight. So Karen Schnell McDonald, who you'll hear from shortly, is the chair of the Watershed Community. Then we have Eli Duker, who was instrumental in getting this group formed. Clara Wallner, who's right back there. Sheila, who's in the back of the room. And myself. They all put a lot of effort into tonight's event, as well as a lot of effort into organizing a lot of the work that takes place for the watershed community. And then just finally, a few final housekeeping items. If you have not yet signed in and received materials that were at that registration table, please do so now so that we make sure we have an accurate list of everybody who is attending tonight. I believe we can and will make PDFs of the presentation and can share them on the website. So if you're interested in some of the details or the links that are provided or resources, we'll make sure that's available to you and we can send out an email blast to the list to let you all know when those are up and ready. We have refreshments available at the back of the room. Feel free. This is going to be 2.5 hour long evening, so if there's any time you need to get up, stretch your legs, get something to drink, feel free to do so at any point throughout the evening. If you are unfamiliar with this building, bathrooms can be found through these doors. They can also be accessed if you just do a loop around there. And finally, if you haven't done so already, please silence your cell phones so that they don't interrupt the many presentations going on today. So our first presentation for this evening. Oh, Claire, can you help me out with that, please? Our first presentation this evening is going to be presented by our chair, Karen Schneller McDonald. Karen has worn many hats professionally. She has been a city planner, an environmental educator, biologist, wetland specialist, watershed planner, biodiversity coordinator, and environmental impact assessment specialist. She owns her own environmental consulting business and has for over 25 years now, specializing in water resources and wetlands, biodiversity, and environmental impact assessments. She's motivated by the idea of making science more accessible to the public. And that motivation led her to write a book, Connecting the Drops, A Citizen's Guide to Protecting Water Resources, to share what she has learned about protecting water resources. She's currently the chair of the Sawkill Watershed Community, as I mentioned, and she is going to be presenting watershed connections. I'm just going to get her presentation up.
Now that I've silenced my cell phone. Can everybody see that okay, or should we dim some of the lights?
It's in bright.
Is it bright?
Good, yeah.
I'm not sure where they are.
Aaron, I'll figure it out.
Okay,
Oh,
thank you.
Somebody else.
Well, my job is to give an overview, a bird's eye view, a summary of enough material that I could probably take a couple days going through. So this is going to be a quick tour. Knowing that, I prepared 2 handouts that I hope everybody got their copies of at the table when you came in. That's for information that I don't get to talk about in this presentation, but that's related. And if you have questions, you might find some of the answers in those materials. So, oh, this didn't change. Is this working okay? It changed
You're at the
here.
end.
It didn't change here. So I need this. Excuse me just for 1 second. I can just do that. To begin that bird's eye view, and to get us kind of all in the same mindset and on the same page as to where we are, that's where we are. And in the little insert in the upper corner, that's the whole Hudson River watershed with the arrow pointing to where we are, just to remind us that even in this watershed, we're part of a much larger system that's connected and interconnected with our water resources. So that's where we are. Who are we as a watershed group? Well, we've changed a lot in the past 2.5 years. We've got a mission now. That's our mission statement, which Carolyn has already mentioned to you. And as I was thinking about how to describe what kind of a group we are and what we do, I was thinking about a recent meeting that we had that seemed kind of typical to me. We had a really wonderful presentation about pharmaceuticals, research about pharmaceuticals in our water by Emma Rossi from the Carey Institute. And then we had a series of short updates. We had an update on the Bard Water Lab and on our water quality data. Then we had an update on the project on the Bard campus to remove a dam, which we've been involved with in tracking. And then we had a presentation about getting involved in commenting on the proposed fencing along the Amtrak route. And that mixture, plus we had refreshments and we had a lot of talking afterward, which we liked. But that combination of topics to me pretty much typified the kinds of things that we're interested in as a group and the kinds of things we like to talk about. So to look at our mission statement a little more clearly, we have hands-on science, and then we'll talk a little bit about education and then advocacy. So for the hands-on science, that's a list of some of the projects that we do that get people involved, to get them outside, to get their hands dirty. They're picking up salamanders, they're planting trees, they're sampling water. All of these things get people together and get them active and involved. And also, some of them produce data that we can use for our education purposes. Our biggest goal here is to develop a base of information that the community can use, that municipalities can use, and that other watershed groups can use as they face local issues and try to solve local problems. Part of that is interpreting science for people, taking a pile of raw data and translating it into something that most people can understand and that they can apply to actually solving water problems. We try to have interesting and varied presentations at our monthly meetings. We are really interested in student research, in having the students at Bard share some of their projects with us and ask questions and kind of interact with our community. And we're also we have a website, and we'll be developing it to provide a resource for the community as well. Advocacy. Now, a lot of people shy away from this word. In my opinion, you can't really be a group that is in favor of protecting water without being a water protection advocate. Different from being an activist. But we like to promote what we call informed advocacy, which means first you gather the facts. And then you look at those facts and verify them and see how you can use them to try to solve some local problems. Part of that advocacy is also inviting the community to just enjoy the watershed, to just get out, get in the water, have a good time, bring your kids out and enjoy it. That's really the first step to getting people involved. Now, our project, our long-term project called the State of the Sawkill, and what we're talking about, part of it tonight, is an attempt to assess the health of the Sawkill watershed by looking at its different components. And there are generally 9 components, there are probably more, but for these purposes there are 9, that you can look at that affect the health of your watershed as a whole. All of them involve interactions between land and water and all of the features throughout the watershed. So we're going to take a very quick tour, through these. There's more information on your handout. I always put this particular picture of the water cycle in any presentation I do, just as a reminder that we're talking about water that travels, that moves between land, air, water, living things, and connects us all. And gives us the reason why we talk about watersheds. Why watersheds? Well, they connect everything. They connect us, plants and animals, the land and the water, and different water resources. They help provide our drinking water, provide clean water, habitat, recreation, and help reduce flooding. The first item that we're going to talk about a little bit is buffers, which are those vegetated areas along the edge of the water, along streams, wetlands, and lakes. And buffers are important because they filter stormwater runoff from the land that carries contaminants. And instead of those contaminants just washing right into the water, they get held up in the buffer, they get processed, they filter through. Buffers are also really important habitat. They're also important for slowing down floodwaters. You can see some of the benefits of buffers listed there. And then some of these pictures, the two upper long skinny pictures are actually pictures of the Sawkill and its buffers as part of a project that we've undertaken to put together those aerial photos, 17 of them, for the length of the Sawkill, and to look at the condition of buffers from 25 feet to 100 feet to 300 feet from the stream channel, and to begin to use that information to inform maybe local land use decisions. Helping us in that process are DEC's Trees for Trips program, which you saw some people planting trees. That was the program that enabled them to do that. And also a new buffer, well, it's actually called a riparian opportunity assessment tool that DEC has developed brand new to help communities plan for restoring and protecting buffers and riparian areas. And we'll be presenting more about this in upcoming meetings. The next feature, watershed feature that can indicate watershed health, are the wetlands and small streams throughout the watershed. We've just developed a map, which you see a copy right there and also a copy on the screen, looking at the surface waters throughout the watershed. But since there is really no map of wetlands that we can use, we've put together the DEC wetlands, some national wetland inventory, wetland habitat areas, and also we use hydric soils because those are wet soils that tend to indicate where wetlands might be located. There's a lot of information about wetland benefits and small stream benefits. One little point that I want to mention, and that the little dark colored photo there on the right hand side, it shows you how wetlands reduce damage to downstream properties during floods, and there are several studies now that are coming out of different municipalities that are looking at that. Floodplains and the condition of banks is another important feature of watersheds. If floodplains are connected to the stream channel and banks are in good condition, water has someplace to go when it floods. When those things are disrupted, we run into problems including increased flooding and increased erosion from degraded banks. Forests, a very important part of watersheds. Forests can be measured as how much forested area you have along the edge of a stream. Forested areas along streams cool the water, provide habitat, increase groundwater recharge, and bank stability, and a whole bunch of other things that I'm not going to go into right now. Ecosystems, the living things and their connections with each other, with land and with water, and with the watershed as a whole, are an important part of watershed health. When the organisms are diverse, the water is clean, and things are functioning well, and everybody's happy, the watershed is healthy. When things start to go wrong and we have invasive species coming in that compete for habitat, that prey on native species, that disrupt the system, then the watershed shows those disruptions as well. We have a lot of diversity in this particular watershed. I just did a really quick survey of the listed species of greatest conservation need in the watershed. These are species listed by DEC, and I came up with well over 24. And those are just the vertebrates, just the fish, mammals, birds, reptiles, amphibians. So there's a lot here, there's a lot to study, there's a lot to cover. The next feature of watershed health has to do with water withdrawals and groundwater. As this graphic shows, surface water and groundwater are all part of the same resource. They're connected. They are connected in all kinds of different ways throughout a watershed, and when you change one part of one feature, often it causes changes in another part of the system. For example, when we pump a lot of water out of the ground using for wells, we can intercept the groundwater that's flowing underground, that's moving down there. We can change the direction it's going, and sometimes we can divert it away from the streams that it's replenishing. And may be really critical to those streams, especially in times of drought. So it's important to know all this stuff so that we can figure out how to solve problems related to water withdrawal and water use. Now we're on to the man-made features or person-made features in a watershed. The impervious surfaces, which are the roads and paved areas, buildings, all the places where water cannot sink down into the ground. These areas cause more storm water to flow across the surface of the land, pick up contaminants, and flow into our surface waters. So we can measure impervious surfaces. I'm not going to go through all the details of this little example of one study that researched, well, how much impervious surface does it take to degrade the water quality of a stream? We know all that, we can calculate it, and we can use it to help maintain our watersheds in a healthy condition. Water quality, last but not least. I saved it for last because we have more to say about that than anything else tonight. For water quality, you're best to check the handout that I gave you. It's got a table in it with 9 common water quality parameters on it, and it summarizes their effects, why they're important, and where they come from. We can look at basic water characteristics like temperature and pH, and then we can look at specific chemicals in the water. We can measure salts or other pollutants or bacteria. And then we can look at where the pollutants are coming from. In the Sawkill, we've been measuring water quality. We had our first spurt of early sampling, and we have, I think, our 2 veteran samplers who were there, 1978 to 1982, sampling now, Sue and Cheryl. You want to just stand up for a minute? Yay. And they're back now, sampling with us, with students and other community members today. And listed there are some of the things that we've been sampling for. We have amassed a lot of data. And we're continuing to crank out that data, right, Eli?
Yes.
Another thing that we can measure in stream is the health of the macroinvertebrates, the insects and other little creatures that live under the rocks in the bottom of the stream. And we have special ways of measuring which ones are there. Some of them are more sensitive to pollutants in the water, and others can tolerate very polluted conditions. So we look at who's there, how many from each camp are there, and kind of weigh the balance and put it through the formula, and we can come up with a whole system for ranking stream quality, water quality, on a scale of 1 to 10. Tracking progress in water protection is something that's going to be an ongoing concern of ours. As we amass all this data, as we try to interpret it for our local communities and try to help by providing information to help solve local water problems, we're looking at how can we track our progress? How can we tell if we're making a difference? If our water is getting better, if it's getting worse, and one of the things that we can use is a scorecard. And there are several different kinds of scorecards that have been used across the country. In Colorado, there's a scorecard for 7 rivers that was produced, and rating those rivers on certain qualities, certain water quality parameters and other items that inform people about how healthy those rivers are. In the Chesapeake Bay, they produce an annual State of the Bay report with grades for specific key indicators of the health of the bay. And they're rated A through F, and we all know what those mean. So it's very easy when you get that one-page summary of their report card for any given year to see, are the grasses doing okay? Are the pollutants, down from where they were last year? Where do we need to work on it more? Here, we are, in the Sawkill, we are putting together a scorecard developed by Riverkeeper, and I think Dan may have a little more to say about that later, which looks at all the array of resources that are available to us as a municipality to help us protect our water. How many of those is the town of Red Hook using and incorporating into its town codes that'll help us protect the water in our town? And by going through this lengthy questionnaire with different topics and different standard resources that we evaluate, we will be coming up with a percent score, not A through F, but percent out of 100, and we'll be able to plan how to better improve our watershed in the future. And with that, we're done. Just a reminder, science, education, advocacy, that's what we're about. Thank you.
So we can take a couple questions if folks have questions for Karen. Yes.
I'll throw one in the hopper.
Excellent.
We just had an interesting attack, and the attack is called the Nestle Corporation. They were trying to get a proposal to buy up the water rights in all of this area so they could send out 200,000 gallons. I'm not sure whether it was a day or a week. Now, they have been under tremendous lawsuit, and they've been applying a lot of muscle. Are you guys familiar with what they're doing?
Yes, we are. And in fact, we've been participating with a task force for the town's Conservation Advisory Council that is reporting to the town board, I think later this month, with recommendations on how to change the town code to prevent that kind of thing from happening in this town. So we are definitely looking at that. And that is the way to go about that kind of a thing. If you're proactive and you put that in your town code ahead of time, you have a much better chance of keeping those corporations out of mischief.
I'll just add one little quick statement.
Yeah.
There is a movie called Flow, which illustrates the problems associated with water as a commodity. I have a copy, and I'm willing to present it in one of your meetings. It's 40 minutes, or go on the internet and look it up. It's very important, and it's important we all understand that.
Well, thank you, because we like to use movies and videos in the mix with our presentations to give people that information. So yes, I'm going to kind of jot that down, and we will. Thank you.
Do we we have time for one more question? All right, Karen has a brief follow-up presentation she's going to make before our next presenter.
Yes,
With help
quickly. If we could have the rest of the leadership team come up here for a minute. We would like to recognize our graduating seniors this year. So as I read off your names, if you could just come on up here with us. We have, I hope they're all here. Chris is
Tierney.
Just Tierney's here?
Yeah.
She's the only one here? Oh my gosh, well, I'm gonna read the names anyhow. Chris Colbert, Tierney Weimler, Carlo Raimondo, Marika Kropitsky, and May Grzybowski.
Tierney, come on up.
And we will get them. Well, that's okay, 'cause Tierney, here's a little bit of
Tierney's a
what
rock
Tierney.
star.
Okay, yeah, she's helped us coordinate, she's helped us sample, She's helped us as a support team for just about every phase of everything we do. So I'm not going to give you all 5 of these because that would kind of be redundant. But you do get one. You get the very first. The very first Sawkill Watershed Community Cap. There you go. And thank you so much.
So Tierney has written an amazing senior project, which I hope to figure out a way to let everyone see. But there are some folks here who star in it big time. It's a very historical view of the Sawkill.
So thank you, Tierney. We wouldn't have gotten to where we are without you.
All right, so our next presenter this evening is Eli Duker. And Eli is an assistant professor at Bard College in the Biology and Environmental and Urban Studies program. And he's also a visiting researcher at the Carey Institute of Ecosystem Studies. He received his PhD from Columbia University, studying the lower Hudson River estuary with researchers at the Mont Doherty Earth Observatory. And Eli's research focuses on the microbiology of water and air and the impact of sewage contamination on what's in our water and the air we breathe. Eli was a driving force behind the creation of the Sawkill watershed community and works with watershed groups to address pressing management questions with community-generated science. Some of his current projects include tracking the effects of road salt application, sewage contamination, and nutrient loading on local waterway health. And Eli's going to be presenting tonight on sewage indicators on the Sawkill. So welcome and thank you, Eli.
So before I get started, I want to tell you a little bit about, we started this journey creating the Sawkill Watershed Community almost 4 years ago now. I came up to the Hudson Valley from the city. I did move from Brooklyn up here. I am one of those. And as soon as I got here, I was very excited about a lot of things. The scenery was a little different than in the city. The water was a little different than in the city, and was very excited to just get started talking to everyone around me about what the Sawkill meant to, not just to Bard, but to the entire community. And so it's been 4 years of learning for me, because I'm a biological oceanographer by training. This water is a lot less salty than what I'm used to. This has been a real learning process for me. And I just want to say that being a part of this Sawkill watershed community has been key to me being able to realize my dream when I was trying to keep myself awake, trying to get my PhD, which was to connect science with community work. And so I'm really excited to present these data. We've all been working hard on these data since 2014, when the very first class that I ever taught at Bard College, that was called Water Quality on the Sawkill, which I think both Tierney and Claire were a part of, right? Was anyone else a part of that? Okay, so and that was the very first college class I really taught, and I remember I was like, okay, we're gonna get out on the Sawkill right now. We're just gonna start doing it, and I took them outside and realized I did not have any clue how to get there. I had been there in my car before, but I had no idea how we walked there. And so for me, it's been a really big learning experience, and I've learned a lot from everyone. So I appreciate your patience with me. I am going to present to you some of the work that we have done now in looking at sewage indicators on the Sawkill. I cannot yet, this is totally just, I'm going to put it out there, I cannot yet tell you that it's leaky septic tanks or not. I cannot answer that question yet, but we're getting close. Okay, so this is our Sawkill. This is a slightly different map, one that was put together specifically to look at all of the sub-basins of our watershed. So these are, as Bob Wills, Bob, where are you, said one time to me, which kind of changed my life, which is, or said to the group, this could be a new way of thinking about neighborhoods. right? And I think it's really powerful. Watersheds are a big neighborhood, and now you can see that there are sub-basins. So these are little sub-basins that are their own watershed in and of themselves. And it's fun to kind of find yourself within those and figure out which sub-basin are you a part of. But anyway, I wanted to show this because when I'm presenting the data, I've pretty much split the data up into 3 areas. And so we sample the Sawkill up and down, so from the headwaters all the way to the mouth. But what we do is we have a couple of zones that are in the areas that are less developed, more agriculture and forested. And then we have an area here which is more Red Hook Town and Village, more developed. And then we have the Bard Zone, which is developed and not in many ways. So, so as I show the data, that's how I kind of split them out. Okay, we have 14 sites that we sample, and we do that every month. Can everyone raise their hand who's been a part of this in some way or another, been sampling? Yeah, great, great, and it's fun. It's a really great way to get to know the Sawkill if you're ever interested. Okay. So when we talk about the Sawkill watershed, we're talking about many services that the Sawkill provide to us and the services that we want to preserve in doing this advocacy and performing stewardship of this resource. One of them is the fact that it is beautiful. We relate to it because it is beautiful. We engage in it because it's beautiful. It lures you in, and it allows us to engage with nature in a different kind of way. It also supplies drinking water. So the town of Red Hook's water supply is in an aquifer that's a part of the watershed. And so whatever we do in the watershed can make a difference to the wonderful drinking water that you enjoy here. It also, the Sawkill itself supplies the drinking water for Bard College. So we pull our water from the Sawkill, we treat it, and we drink it. So the Sawkill is very much a drinking water source. The Sawkill watershed maintains that clean drinking water source. Also, you see the toilet there and the wastewater treatment process underneath. The Sawkill performs another really great service, which takes our treated sewage away. Okay, so there are 2 places on the Sawkill where there are treatment plants that are putting the effluent into the waterway, and the waterway is taking that treated effluent away, and that is in the Red Hook Commons, which will soon become the Red Hook Village's sewage treatment plant, and Bard College. And this is a big service that the Sawkill is providing for us, because what it does is it takes the treated sewage out, it dilutes it, and takes it down to join the Hudson River and then eventually the ocean. And the other service that it provides that Karen mentioned, and we will talk much more about later, is that it actually takes water when there are huge events, huge precipitation events, and funnels it away from us. Okay? And so these are some main services that we're trying to preserve with the Sawkill when we're trying to advocate for keeping it healthy. Are there other services that folks can think of that the Sawkill provides?
I'm sure there's a lot of life in it.
Yep, right? So it's ecological, right? Yep. Other services?
Recreation.
Recreation, okay. Yep. Who's swum in the Sawkill before? Yes, good. Not on purpose, you said?
No, I said ankle deep.
Oh, yeah, all right.
Like swimming.
Okay. Any other services that the Sawkill provides?
Education.
Education, okay, all right. So it's a point where you can start learning. Yeah. Okay. Yeah.
I always say, like, water, like, especially at this size, it's just a magnet for kids. So it's like, it's the playground.
Right. It's a gateway into the. All right. Okay. Yes. So when we think about the services that the Sawkill provides, we know that it's beautiful. It's an entryway for kids and adults. We swim. We try to canoe or paddle in it. Sometimes more successfully than others. So we know these things. What I'm interested in when we think about sewage is where the services are provided here in terms of drinking water. And those services have a place. There's a location in there are locations in the watershed where those services are provided. So in terms of Red Hook's drinking water source, the aquifer is located in this region, and the water is flowing this way. And Bard College's drinking water is pulled out near Bard College, which makes sense. So there's two areas where we are protecting drinking water sources. And then there's also two areas where we are sending our treated effluent from our toilets and our showers and our sinks right back into the Sawkill. So we're drinking the water and then it's going right back after being treated. And that's also, so the Red Hook Commons area is near where Benner Road crosses the Sawkill. Some folks live near there, correct? Or, yeah, you know where it is? Okay. And then there's the effluent that comes in from Bard College. Okay, so those two services is what I'm going to focus on in terms of trying to think about the effect of sewage contamination on our waterway. Okay, so why does sewage matter? Why do we care if there's sewage in our water? Not a trick question. Why does it matter?
We don't want to get sick.
We don't want to get sick, right? We can make us sick. What else can it do? It changes the ecosystem. Mm-hmm.
Excess nitrogen and phosphorus.
Right, so that will be basically fertilizer for the aquatic life, right? It changes the ecosystem. Yeah. It smells bad. That's also one thing. Anything else you can think of? Okay, so we don't want sewage in our water, right? We don't want untreated sewage in particular because that can cause real issues. So when sewage is put into a waterway, both treated sewage and raw sewage. So the difference between treated sewage is that it's been through the waste treatment plant process. You're trying to remove some nutrients. You're trying to remove all of the bulk that's coming in. And you're also trying to kill off the pathogenic bacteria. Those are kind of the three things you're trying to do before you send that water back out into the world. But what we know from sewage is that both treated and raw sewage can be fertilizers, as you said, and lead to eutrophication, which can lead to massive algal blooms in slow-moving waters, in warmer waters. So it's the kind of thing we want to avoid, right? We also know, as you said, that sewage contains human pathogens and allergens, and that the sewage, as we've recently learned in very detailed manner, sewage contains pharmaceuticals, antibiotics, and personal care products. And those are the kinds of things that we're still trying to sort out in terms of what is the ecological impact of that. Okay? So we're interested in not having that on the Sawkill. What sources of sewage contamination could there be on the Sawkill? We know that there are two waste treatment plants that are putting effluent in. So we have treated effluent going in. We also have a hunch, and this is why that initial question came to me as one of the first questions I was asked about the Sawkill, which is, are there leaky septic tanks contaminating the Sawkill? And when it's a leaky septic tank, that's when you get raw human sewage in the waterway. Right? So it's not treated, it now is raw, and that will contain more pathogens than your treated effluent, right? And then we have runoff from surfaces, right? So you can have human waste moving in through water sweeping over the surface and dragging debris along with it. You also can have cows, pigs, you can have snapping turtles. They all poop, right? So you have the introduction of animal waste into your waterway as well, okay? So when we're looking at ways to detect whether or not there is sewage contamination, we're going to use two different ways. One, we're going to look at the fecal bacteria, and the other one is we're going to look at nutrients. So if you look at fecal bacteria and you see high levels, that's usually raw human sewage or runoff from surfaces. When you're looking at your treated effluent, you may get occasional high fecal bacteria measurements, but you're usually looking at the effect of nutrients in that way. So the fecal indicating bacteria, we call them FIBs. I'm going to take a look at what we looked at in 1976 to 1982. There's no we there, I was not there. But what the community looked at, and then what we're seeing in 2014, 15. So in the first iteration of our water quality monitoring program called the Sawkill Water Quality Surveillance Program, we were looking at fecal coliforms. Okay, and so fecal coliforms, you take the water, you filter it onto an agar plate, you let them grow up overnight, and then you count them. Okay, and in the monitoring program that we do now, and that is Sue with the rockin' boots there, and other members of the Sawkill watershed, I believe at Benner Road actually, we are sampling Enterococcus. Okay, another sewage indicating bacteria. Their presence is we think indicates the presence of other pathogens and a full suite of what comes in when there's juicy sewage going into your waterway. Okay, so we have from 1976 to 1982, when we take a look at the values at our study sites that we are looking at now. You can see that, so this plot basically shows you where you get the blue area is where most of the data fall, okay? So when you look at the blue areas and you see the red line, which outlines kind of what you would like to see in a healthy waterway. And so here, these are site numbers, and this is Bard campus area here, this is Red Hook area here, and then these are the headwaters up here, okay? So what do you notice from that? Can you see that red line?
We have a problem towards the headwaters.
Yeah, we've got problems everywhere. We've got blue crossing the line. So I can see very quickly why in 1976 you decided to start sampling. And apparently it worked. Okay, so now we're measuring Enterococcus. The red line is for what you want to see in terms of Enterococcus in your waterway. And for the most part, the blue is below the lines. Right? There's only two spots where the blue rises above the line, and that's at sites 5 and 6. Site 6 is Benner Road, which is below Red Hook Commons. 5 is just downstream from Site 6. And you also see that sites 9 and 10, which are where the Sawkill comes into the waterway, is edging up towards it, although it's not above. Okay? So, and after 4 years of sampling, I think it's safe to say that there's something at Benner Road that we need to take a look at. Okay?
Where's Site 7?
Site 7 is the bridge. The bridge at the rec park. Is that right?
Linden Avenue Bridge?
Linden,
Oh, it's Linden. Okay, sorry. Linden. See, I don't get out on that.
this is where the rec park is, this is the Linden Avenue Bridge.
All right. So what I've done here then is outlined the two places that we should probably be taking a look at in terms of sewage in our water. Okay. One is the Sawkill here and where it comes in, and the other is Benner Road. And what I want you to notice is that with the Red Hook's drinking water supply, as long as the flow is this way, it's not going to be a problem. But Bard College's water supply, that is downstream of both of these kind of hotspot areas, and so that's a concern. Okay, so potential next steps. All right, so potential next steps are having higher resolution sampling near Sawkill sites and attention to treatment processes at the Red Hook Commons treatment plant. The interesting thing about this is that Red Hook Village is about to take this over, and so it's something that we're hoping we can change moving forward. Now, so there is another indicator, as I said. So you've got your fecal indicating bacteria, which are the most exciting to me, and then there are the nutrients, which are the fertilizers that we were talking about. And those nutrients can be nitrogen or phosphorus. And so what I did was I compared measurements of nitrogen and phosphorus from 1976 to 1982 to the present. And so with phosphorus, again, the red line is showing you where you want your waterway to be. You can see that in 1976 we had a huge issue with phosphates in the water, and now we don't, right? So that's good. I'm assuming, Stuart, you'll have a few things to say about that. Yeah, I don't want to, okay. And then with nitrate, okay, so we have nitrate, And we look at what 1976 to 1982 is. I like that it's pink. It kind of matches my tie there. So the 1976 to 1982, comparing that to where we are now, what do you see? Not much difference, right? And actually, if you look at these black lines within the boxes, the colored boxes, give you a sense of the average or the mean. And there is a statistically significant difference between those two. And that points to us actually starting to increase nitrates in the water. And I'm supposed to stop. All right, so this is the last one. I wanted to take a look at, okay, if we're seeing increasing nitrate, where, why, how, what's it coming from? So I made this chart which lays out all the sites. You got Bar, Red Hook area, and then low development and ag. And the gray behind it is what we had in 1976 to 1982. The blue is what we have now, and it's just a spray of all the points we have so far. And what I want you to take away from this is that the increases appear to be more pronounced as you get into Red Hook and onto Bard campus. And so, and Site 6, which is that Binner Road right below the Red Hook Commons, actually is starting to be pretty high. And so the sewage issue and the effluent issue may be something that we need to be taking a closer look at in terms of nutrients as well. Okay? And that is it. Thank you very much.
So we can take one, maybe two questions for Eli at this time.
How did you measure the nitrate?
The nitrate, so in the 1976 to 1982, those measurements were made using, I think they were Hawk kits. And in nowadays, it's made at Carey Institute, so.
Any additional questions?
This be lawn fertilizers? What?
I don't know. I think it's a question. I think it seems that it's related to effluent, which is not too surprising since that's not a regulated piece yet. And then the other thing could be lawn fertilizers. It could be runoff. Impervious surfaces increase with the developed areas, so it might be just more material moving. I don't know. I think it's something we need to look into though.
Is the processing of our sewers that are going in our backyards, is that going to be done in the common site?
Yes.
So in fact, the village is going to have to be even more vigilant in terms of how that site is managed and maintained to push this down.
That's what this suggests.
Right, okay, thank you.
Could it also be possible that the overloaded septics within the village that are being addressed by the sewer
Could be
are,
contributing.
Through
And that's
groundwater
Right. And so-
reaching the street?
Right, and that's something that we will. I'm assuming since it's tough to figure out whose septic tank is leaky. Folks don't like to talk about that, but it's tough to figure that out. But once it comes online, it'll be interesting to see if it changes the readings that we're getting along the Sawkill, and if it becomes more concentrated.
So that might then have implications for extending the plant, because right now it's just going through
It may.
the heart.
Although there are consequences to concentrating the waste and sending it out one pipe, so there are things to weigh on both sides.
All right, thank you, Eli. So our next presenter this evening is Dr. Stuart Finley, and Stuart Finley is an aquatic ecologist at the Carey Institute of Ecosystem Studies. His research interests span habitats and ecological processes in aquatic ecosystems with a strong emphasis on bringing information to management and application. He has studied streams, wetlands, and rivers broadly with a focus on the Hudson Valley of New York. And he is a member of the Hudson River Estuary Management Advisory Committee and has been active in advising numerous undergraduate research internships. And Stuart is going to be speaking tonight about nutrients in the Sawkill, the context and consequences. So thank you, Stuart.
Thank you, Carolyn. And again, thanks everyone for coming out. It's great to see a group of people that are sort of engaged with their watershed. There are a lot of sort of orphan watersheds around the valley that aren't getting this kind of anywhere near this kind of attention. So it's good to see that some are. So what I'm going to do, in I hope about 10 minutes, is talk quickly about why these nutrients matter. And Eli set the story up as to just what the levels are like, and gave you one little snapshot, actually 2 points in time, as to the comparison across 20, 30 years. I'm going to give you a little bit broader context here. You heard about the Sawkill is embedded in this bigger system, so I'll give you some comparisons to data for other streams in the region to see if the Sawkill is sort of, kind of like the rest, or if it's unusual in some way. I'm going to talk more specifically about long-term trends, because that really does give you a sense of, are things getting better or worse? Is this something we need to be paying more attention to, or can we turn our attention to higher priority issues? And I'll touch on the sources in a slightly different way from what Eli did. I think the message is going to be pretty much the same, but that's kind of what we're trying to do today, is get the information out there and then have a back and forth as to what does it mean and how might one act upon that. Okay, so here's the watershed again. This is from a very useful tool called StreamStats. It's a USGS tool. So for any stream you can see on a map, you can get the watershed delineated. It gives you land cover, and you've already heard about these numbers. It's mostly forested. The watershed as a whole is mostly forested. There's a relatively small amount of what they categorize as developed area. And the impervious cover is actually pretty low. It's only about 3%. So that's good. So Karen showed you some numbers earlier. And you can find spots in watershed that are above 3%, but the average is only about 3%. Many of the data I'm going to show you come from sampling that the Research Reserve has done, and this goes back to 1991, so it's a really good long-term continuous record. That's the good part. The not so good part is it does not go up into the watershed. So Eli showed you data from different points up tracking the stream in different sub-watersheds. The information that the Research Reserve captures is only at it's almost all the way at the bottom of the watershed. So it's great for a long-term perspective. Doesn't tell you what's happening within sub-watersheds spread throughout the rest of the area. Okay, so in many of these slides, I'm going to show you sort of the underlying information, which is way more gory detail than anyone wants to try and digest at this point in time. But if you want to come back and look at it later, this is where the gory detail is. And at the bottom, I've got sort of a schematic, which is really what you ought to care about. So nutrient, Eli, both Karen and Eli alluded to the fact that nutrients cause a problem. To a large extent, that problem comes about because they drive high algal abundances, and you get these bright green waters, which sometimes are a problem in and of themselves, sometimes are a problem because of odor, sometimes are a problem because of the kind of algae they are. There are a whole bunch of things, and you wind up with these problems. And the EPA uses a much more complicated scheme, and you can go through and find your benefits and find your indicators in this chart. We're not going to do it now. But they put a lot of thought into this, and they use this scheme to identify what are called impaired water bodies. And if a water body is not meeting what they think is the best use, you try and work your way back and figure out, well, what's the indicator, what's the cause, what's going to be the solution. So the very complicated way, the simpler way is down here. So we care about nutrients largely because of what they do to algae, although not completely because of what they do to algae. And it can cause a variety of problems. So I'm going to spend most of the time talking about both nitrogen and phosphorus in the Sawkill, and sort of what are these levels like, how do they compare to other places, and how are they changing over time. So here's a very nice survey that was done by Dave Burns when he was with the Dutchess County Environmental Management Council, and he sampled about 14 streams throughout Dutchess County across a full year's worth, monthly sampling across the full years, and this was his master's thesis at New Pulse. Actually, the top panel is nitrate, and the bottom panel is phosphate, and the red arrows indicate the Sawkill. Again, the sampling point for this was at the base of the watershed, not some point further up in the watershed. And so if you look at this and compare just the height of the bars for either the top panel or the bottom panel, the Sawkill is not the worst stream in the county, and it's not the best stream in the county. And actually, I'm not sure I want to get into best and worst a great deal. It's kind of in the middle of the road, and that's going to be the message throughout this. It's a site that has moderately high nutrients. It's got agriculture, it receives atmospheric deposition, it's got people that live in the watershed. You're going to have some nutrients in the water. It doesn't have terrible water quality problems, so again, kind of middle of the road. And comparing it to these other sites, again, kind of a middle of the road situation. If you wanted to pick a water body to start with for either nitrogen or phosphorus, the Sawkill wouldn't be either one of those. All right, there are worse places that need the attention more than the Sawkill does. So partly good news, partly keep paying attention. So this is a comparison just to streams in Dutchess County. I'm going to show you a more sort of global picture, and I don't want you to worry too much when I first flash this up here, because everybody will leave the room. So this is a much broader comparison of streams. It's 200 sites around the world where a variety of the necessary information have been gathered. I'm going to take about a minute to walk through what this really means. So across the bottom of the bottom one, this is phosphorus. And for the x-axis on the top one is nitrogen. And again, the red arrows indicate where the Sawkill falls. So if you look at that range and you look at where all those dots are across in horizontal space, the Sawkill's about in the middle. So for streams in this broader data set, the Sawkill's falling about in the middle, as I said before. Sites way down here are pristine, forested headwater sites, no people, no row crop agriculture, nothing like that. Streams that are far out on the right-hand side are intensive agriculture, cornfields, high fertilizer application, tile drainage, that sort of thing. So you've got some really pretty bad sites and some really, as close to perfect as you can get. And the Sawkill, again, is falling sort of in the middle of that. I also point out this is a log scale, so there's a huge range in concentrations here. Okay. Up the y-axis is essentially a measure of how green the stream is. All right, so as you move up, the stream gets greener and greener, and the three different curves are sort of different thresholds that these authors were talking about. So for simplicity, so before I go on, the axes clear, because if the axes aren't clear, it's going to be hard to get the rest of it. So this is how much nutrients a stream has, and up the y-axis is how green it is. Okay? So again, the Sawkill is sort of in the middle on the nutrient axis. And what's relevant here is if you look, we'll just look at this top one. You see the shape of that curve, right? It sort of doesn't change much further to the left, changes steeply in the middle, and sort of flattens out at the top. All right? So the fact that the Sawkill is in that middle portion, again, it's either really good news or pretty troubling news. The good news is that if you drop the nutrients a little bit, if you move to the left a little bit, you move down the steep part of the curve. And you get a pretty significant drop in the greenness of the stream fairly quickly. All right? Just imagine that you're out here on the flat part of the curve. You could drop nutrients and see no response. Right? You're still going to have the same amount of greenness. The fact that you're on the steep part of the curve is important here. You're in the middle of that. So if you drop nutrients a little bit, good news, you should get a pretty significant response. Who wants to guess what the bad news is?
When you go the other way.
Yeah. So if you're not careful about it, you start going the other way, you get a steep response in the green direction. All right, so you don't want that. Okay. So knowing where the stream is and sort of these global relationships gives you some idea of what might happen if you either take action to reduce nutrients or get careless and don't pay attention to what your nutrients are doing. Okay, so you're in a sensitive spot is kind of what it means. Okay, and we can come back to this in the questions. I know it's an ugly figure. There's just no choice. But I think the message, if we get the message across, it's important. Okay, so let's talk about long-term data. So these are the research reserve data. It goes back to 1991. And again, it's at the mouth of the Sawkill, not further up in the watershed. Lots of variability, these monthly samples, a fair amount of variability across months, which you've seen in your own data. Eli showed this big range in most of the sampling. The concentrations Eli showed, I forgot to put the units on here. My concentrations are about what Eli showed, so that's good. If you look at 2005 on, and I haven't done the stats on this, statistics on this, I would argue there's going to be a decline there. All right, and Eli's a little bit worried with this 2 time point thing Dan wants to ask a question.
Is the sampling point in the tidal?
No, it's
Above
it's
the
where
right.
it discharges, but it's
Okay.
just above the tide. Yeah, so it's the Sawkill Creek, but they're trying to capture the loading tube to the south there. So I think there's a slight decrease there, and Eli in his 2-point comparison was arguing for an increase, and that may be true for those 2 points. I think overall at the mouth, there's probably, these data seem to indicate a decrease. They sure don't show an increase. All right, I'll say that. This could be because atmospheric deposition has improved, which it certainly has, and we should recognize that that management action has had some effect. So I do think there is a decrease when you look at a sort of continuous long-term data. So this is sort of encouraging for that location at least. Although your Bennett's Road looks pretty problematic. Here's phosphate, and this does not go back to the pre-phosphate ban times, just for the record. There's one wonky year that nobody can understand that I won't pretend either. But most of the points are pretty low. All right, and again, the numbers agree with what Eli showed. I'm not seeing any particular time trend here. We could dig out a little bit deeper, but it's certainly not getting worse, and they're showing low concentrations since the phosphate ban. So what's causing variation in nitrogen or phosphorus in streams in general? This is going back to the Dutchess County survey that was done. So here's the concentration of either nitrate or phosphate plotted against percent agriculture in that watershed. And again, these are the 14 streams distributed around Dutchess County that would have different proportions of agriculture in the watershed. Some 0, they have no agriculture, and there's one out there that's 40%. I would have to go and look up who that is. In general, there's a very weak relationship. It's not like there's a smoking gun here that says agriculture is your problem. If you look across the nation, and you get some really high intense agriculture sites involved in an analysis like this, you get a pretty clear indication that agriculture is a problem. If you look across these streams in the county, we don't see that. So sure, there's agriculture in the watershed, sure there's nutrients involved with that agriculture. It doesn't look as though it's really a problem here for streams in Dutchess County. Okay, so the take home, the really good news about all this is that, well, one, you're all here this evening to contribute and hear about this. The Sawkill is well studied. There's a lot of information. We're just going to barely scratch the surface this evening. There's a lot more that is known and can be brought to these kinds of questions you guys are asking. The nutrient concentrations are moderate. This is not a forested stream that has no humans around it and doesn't have any agriculture, no pipes running into it. That's not the kind of stream it is. So it's got moderate nutrient concentrations, are kind of typical for what's around here. It's not the worst stream in Dutchess County by any stretch of the imagination. And the resultant problems in algae, odors, I think we're in macroinvertebrates, same story. You'll find some spots where there are little problems here and there, but they're not widespread and they're not severe. So the stream's doing pretty well, and let's keep it that way. Okay, so thank you all very much.
So, anybody have questions for Stuart? You just present it so clearly. Or we're all mind blown. Some time to process. All right. Well, thank you, Stuart, again. Our next presenter, Kate, could you really pronounce your last name for me because I don't want to butcher it as she inserts a piece.
Sorry. Meyer-Dirks.
Meyer-Dirks, thank you.
Sorry, I just needed some sugar.
That's it. Dr. Catherine Meyer-Dirks is Associate Professor of Environmental Studies and Sciences at Siena College, where she teaches courses in watershed management, environmental field techniques, environmental research methods, geographic information systems, or GIS, and analysis techniques for soil, air, and water. She received her bachelor's in science and civil engineering from Tufts University and her PhD in environmental engineering from Princeton University. And for the past several years, she and her students have been collecting field data and doing GIS mapping in the Sawkill and the Patroon Creek watersheds, both which are tributaries to the Hudson River. And Kate's going to be presenting on road salt impacts on water quality, watersheds, and communities. Just get her presentation up. Thank you, Kate.
Great, thank you. Alright, so I have road salt, and so, as Carolyn said, I'm from Siena College, so I have the outsider's perspective. I work in watersheds in Albany, so much more impervious than 3%. That's unheard of in my parts. But anyway, so last week Eli sent me these two figures. And he and Carolyn tasked me to develop this talk that would talk a little bit about what all these data mean for the Sawkill watershed, water quality, ecosystems, and all of you, the people of the Sawkill watershed. So over the last few days, that's what I've been trying to do. So I've been trying to think, okay, well, what do these charts mean? What are these data? What are these data telling us? And so in order to make sense of these data, I did a couple different things. So first I had to think about, okay, well, what is Eli and the Sawkill watershed community, what are they actually measuring and how? I also wanted to put these numbers, or compare these numbers to national and state trends. And compare these numbers to national and state criteria. So what I thought I'd do for the presentation is just bring you through my journey. So what did I discover when I did those three things? And here it is. So first of all, I want to think about, okay, well, what's actually being measured here? So when we measure salt concentrations, there's a few different ways we can do it, myself included. So a lot of times we'll put loggers out in the stream channel, and that measures salt concentration. A lot of times we'll go out with a, ooh, got a little messed up. So switch these two. Here, I'm not sure what happened, but a lot of times we'll go out and we'll use probes that will measure salt concentration. And then a lot of times what we'll do is we'll take what's called a grab sample, so we'll actually grab a water sample in like an Nalgene bottle and bring it back to the lab to do analysis. And so what we're actually measuring, we could be measuring a couple different things. A lot of times when we think about salt concentration, we think of salinity, because that's like salt concentration in oceans. So salinity is a measure of the total salt concentration, comprised mostly of sodium and chloride ions. Which are that's most of the ions that are in seawater. But the problem is that it's really it can be hard to measure salinity out in the field. So instead, a lot of times what we'll be measuring, especially with those loggers and those probes, is this thing called conductivity. So conductivity is a measure of the water's ability to pass electrical flow. And this is directly related to the concentration of ions in the water, including those from dissolved salts. But the problem is that conductivity can depend on temperature. So a lot of times we'll normalize it by temperature, and so that's what we're talking about when we're talking about specific conductance. Or sometimes we're measuring chloride. So chloride's a little bit different. Chloride is just the measure of chloride ions. I think that's my best understanding. As you heard, I'm an engineer. I got a C in chemistry. So I really am bringing you through my learning process. So in general, when we're looking at these different measures of salt concentration, because chloride is just the measure of chloride ions, a lot of times the concentration will be lower than salinity. That's what's being shown on the chart up on the right there. But in general, specific conductance or conductivity or salinity is going to be directly related to chloride concentration. Sometimes that relationship is linear. It depends on where you're measuring those things. Okay, so then once I reviewed my definitions, I took out my old chemistry textbook, reviewed the definitions. The next thing I wanted to do is take a look at the numbers that Eli sent me for the Sawkill and just make sure that everything's below what the EPA and the New York State Department of Environmental Conservation says it should be. So the EPA water quality criteria for aquatic life says that the concentrations, like the 1 hour or the maximum concentration should be below 860 milligrams per liter. Longer term, continuous concentrations below 230. The DEC has similar criteria. They say for our A-class waters, that's like our most pristine water, we want it to be below 250 milligrams per liter. And then also the EPA has secondary standards for drinking water. And what this says is that the secondary standards are all about how it tastes, not health standards. So they want water to be below 250, or else it starts tasting salty. Okay, and then the next thing that I did was take a look at my salt literature and reread it and ask myself, okay, so what do we know about salt concentrations in surface water and groundwater, both nationally but also in the Hudson River watershed? And so, to summarize some of the things that we do know that salt use has increased in the U.S. over the last few decades. We do know that salt concentrations in surface waters have been increasing in most places, or in a lot of places in the U.S., and this is tied to salt use. As urbanization, impervious surfaces, and proximities to roads increase, so do salt concentrations. These concentrations can often exceed EPA criteria. And then salt concentrations are generally higher in the winter, but sometimes they can also be elevated in the summer. And we have some great research out of the Carey Institute that talks a little bit about why that is. So that's a summary. I have a few slides that just sort of demonstrate what we know about salt concentration. So here's a few figures from the U.S. Geological Survey put together that shows that salt use in the United States since 1975 to 2003, so it's a little bit dated, has been increasing. And then on the right there, the green line is the salt use for de-icing. So we can see that in general the trends are at least up until 2003, salt use has been increasing. And then the next picture is a nice, I think, a nice summary of a lot of the other points. So what's being shown here is that this is chloride data from several different watersheds over the United States. And what we can see, there's a few points that the chart is making, is one, that salt concentrations are increasing with time. They're also increasing as percent imperviousness increases. So that's what's the redder charts are the more impervious watersheds. And again, impervious surfaces are like hard surfaces, roads, buildings, parking lots. And what we can also see is that the black lines are salt concentrations in the winter. So generally they're higher in the winter, right? Which makes sense because that's when we put salt on our roads. Another picture that's showing a similar thing, one that salt concentrations are increasing in these watersheds over time. So the blue line is 2006 to 2010. Yellow line is the 90s, and so we can see that salt concentrations are higher in this later snapshot of time. They're also increasing with percent urban land cover. But the other thing that the chart is showing is that the number of days where salt concentrations are exceeding the EPA water quality criteria are also increasing. But this isn't happening everywhere. So another study showing that trends across the United States. So in the Northeast and the Midwest and the Southwest, salt concentrations are in fact increasing. That's what's being shown by the red coloring. But in some parts of the United States, they're actually decreasing. So in 37% of our watersheds, salt concentrations are increasing, but for different reasons. So the data suggests that in the Northeast, those salt concentrations are increasing due to road salt, and but for example, in the Midwest, it's due to fertilizer. So there's been a lot of great research that's looked at trends over the United States. There's also really great research regarding salt concentrations that have been done here in the Hudson watershed. So a lot of great work from Stuart and other folks at the Carey Institute. He's not here, I can't congratulate him, helping with my presentation today. But so a few studies out of the Hudson River watershed. So Vicki Kelly and her colleagues at Carey looked at salt concentrations in people's drinking water wells, and have shown that actually they measured chloride as well as sodium, and showed that in more than half the wells the concentrations of sodium exceeded EPA health standards. They also, Vicki Kelly and colleagues also looked at Wappinger Creek. That's what's shown in this B slide here, or B chart, and what they saw is that right along with those national trends, salt concentrations are increasing. They're also higher in the winter. Oh, Stuart is here. Yay! Hiding in the back. But what was interesting, what I like about this study is what the data suggests is that the salt concentrations are increasing with time, not necessarily because of increased salt use, but because there's some suggestion that, over all these years that we've been pumping salt into the environment, it's actually hanging out in our soil, and during the summer when it rains, that salt is getting flushed into the stream channel. So some interesting findings there. C, same thing in the Adirondacks. So this is looking at salt concentrations and road density. So as road density increases, so do salt concentrations. And then finally a study done in the Mohawk River Basin that showed that between 1950 and 98, the volume of sodium and chloride in the Mohawk increased by 130 and 243%. And they suggest due to urbanization and road salting. Okay, so why is this important? Well, if we use the water for drinking water, and it exceeds that 230 milligram per liter concentration. It's just going to taste bad. No one likes to drink salty water. But then there's also a suggestion that increased chloride concentrations in surface water can be linked to lead pipes being corroded, and this is part of the problem in Flint. And so I don't know if Dan's going to talk a little bit more about that. But and then also there's lots of studies out there to suggest that salt levels above and below that EPA ecosystem health criteria has impacts on both aquatic flora and fauna. So Stuart and Vicki did a really nice summary of some of those impacts in a study in 2012. Okay, so then once I went back and I reread my literature, I did my homework, I sat back down and took a look at the data for the Sawkill. And so I think the take-home message here is if we look at the Sawkill data within this larger context, what I think some of the take-home messages here are that for watersheds with comparable percent imperviousness percents, as Stuart said, is about 3%, we are seeing concentrations of chloride that are a little bit higher than some of those other watersheds, but also lower than other watersheds. So again, I guess that's the big take-home message, sort of in the middle here. But the concentrations are approaching those that may have some ecosystem impacts. But even so, they are well below the EPA criteria and the DEC standards. As the same story with bacteria and maybe the nutrients, salt concentrations are increasing over time, consistent with trends for the Northeast, and they are increasing with increasing urbanization, consistent with U.S. trends, including Hudson River watershed trends. And then I will just point out that although we're seeing salt concentrations increasing, it isn't necessarily because that we're using more salt. I'll admit I didn't take a look at data that shows anything about how much salt is being used in the Sawkill, but based on some of the other studies, although we're seeing these increased concentrations of chloride, it's not necessarily because of increased salt use. It could be due to salt that's already in the environment. And so there's lots of research going on right now that's looking at just that fact. And actually, I think that's why Eli asked me to talk about this, because we're looking at that issue in Sawkill and the watersheds that I'm working in as well. Okay, that's it.
Great. Do we have any questions for Kate?
Has there been any research into the impact of water softeners where salt is being used and then flushing through into the watershed through indirectly perking into the ground?
Yes, I'm sure there has. So I'll admit I'm new to the, I don't know, maybe Stuart might be able to, or Eli might be able to answer this question.
Sure, I think we
more.
see high conductivity in sewage effluent, treated waters, particularly at Fenner Road, so that might be one of the reasons, the water softeners. They do increase salinity of the waters.
There's huge amounts of salt, going into people's water softeners.
Yeah, absolutely, yeah.
It's flushing out somewhere.
Yeah, just realize it takes a lot of water softeners to come anywhere close to what's applied to the roads. We're talking about hundreds of pounds per mile per event. So water softeners can matter, but you need a really high density residential area for that to matter.
Is there an alternative to using salt?
Yeah, so there's been lots of work that's looked at alternatives to traditional road salts, and some of the research suggests that that it does have an impact on salt concentrations. I think the problem is that some of the research, especially that's come out of the Carey Institute, is that even if we reduce the amount of salt that we use, because there's so much in the environment, it's still getting there, regardless of whether or not we use beet juice or whatever to desalt or to de-ice the roads.
What kinds of concentrations of salt in water are sort of threaten water infrastructure systems?
Yeah, that's an excellent question, and I anticipated that question. And so I reread one of the studies that looked at that issue, and to see if I could make any conclusions about what's happening in the Sawkill and potential for corroding drinking water infrastructure. And again, to the best of my understanding, is that there's like the criteria to know when the pipes are going to corrode versus when they're not. It's a different type of measurement than we're doing in the Sawkill. It's chloride. It's the chloride to like sulfate ratio, something like that. So I didn't want to make any assumptions about what would be happening. That's why I sort of passed the buck to Dan. I thought maybe he would address it.
And luckily, there's a whole presentation in between now and then, so.
So you can have that.
Forgotten that question.
But yeah, no, that's an excellent question. I just don't know. Beyond my level of knowledge.
So our last question.
Yeah, thanks for the presentation. I was wondering, what would be the effect of climate change on this, and is there a suspected relation to like changing levels both up and down?
Yeah, so that is a great question about climate change. So I think so. That's a good one. I didn't think about that one prior to the presentation, and so maybe Eli or Stuart has an idea about this. But I mean, I think in general, right, with climate change, we're going to see more extremes, right? So. I think part of what I would say is with climate change and more extreme. So I'm gonna talk from a more urban context because that's what I'm more familiar with, right? So in urban environments, we definitely have when it rains, it really rains, and when it's dry, it's really dry, right? So there's less base flow. So when we see less base flow, all of this salt is. If it's coming from the groundwater, it's going to be much more concentrated. So, you're likely to see bigger impacts if we're looking at concentration. The other thing is that there may be a lot more fluctuations as well. And so, when I was reading the studies, one of the points was that there's a lot of organisms that can do okay when it's salty, like brine water, and there's lots of organisms that do great when it's fresh water, but there's not as many that do well when there's those fluctuations. So I think that's going to be the big problem.
Great, thank you so
Thank
much,
you.
Katie. So our next presenter is Jen Kavanaugh. And Jen has over 15 years of experience as an environmental scientist working in the areas of stormwater management and water quality assessment and protection. She's a former employee of Fuss & O'Neill Consulting Engineers, and in 2017 this firm won and in 2018 completed a funded project to study and advise flooding issues within the Sawkill watershed. Jen served as the local liaison and a project coordinator for this study. Jen is currently a Red Hook resident and a member of both the Sawkill watershed community and the Red Hook Conservation Advisory Council. So thank you, Jen. Alrighty, so now we're going to talk flooding, and it has been touched upon by others, so maybe some overlap, but we'll see where we're at. So, what is a floodplain? A floodplain is kind of the flat area that's next to a river, and then the surrounding banks and valley that fill up when there's a storm. So if the storm comes, water has to go somewhere, it goes down a hill, goes to the streams, and as the streams fill up, it fills up the floodplain, okay? There's two parts to the floodplain. It's that floodway where the stream is normally, kind of like where it does its work, and then the flood fringe, that part that fills up as the water comes down. As Karen touched on earlier, there are many natural processes that are happening in that flood zone, in the floodplain, including the birds and bees and flora and fauna and all that special stuff. But also the stream is moving. It's eroding, it's cutting, it's meandering, it's doing what it does to live. The stream has to live too. So it's working around in those areas. And then we have to remember that additions to that floodplain, they do happen and they can change things. I'm looking at Carolyn here. I'll use the baby in a bathtub. So you have, if Bard kids, you'll get there one day. You have your firstborn, you get the little bassinet thing ready, you got the little tub, you fill it up with just the right temperature water, and then you put the baby in and you realize I put too much water in, there's water, comes over, and it's on the table. So when you put a lot of things in the floodplain, when the water comes in, it fills up higher. So you have to take account for the baby. I also like to think of floodplains as guest rooms. Okay, so you don't need them all the time, but when you need them. Kind of like when your parents come to visit. Okay, you got to put mom and dad somewhere. All right. So you kind of don't want to. My guest room. Let's tell you my little secret. It's full of laundry when it's not in use. But that's good, because when mom and dad come, laundry's out, mom and dad are in. You gotta avoid putting permanent things in there, because if you decide to turn your guest room into a closet or a man space or something else with permanent things there, it's gonna be a little impossible, it's going to be impossible to move that out and to move mom and dad in, which means you've got no bed and you're sleeping on the couch. So, let's think about what we're putting in the floodplain, make sure it's not permanent, make sure we can get it out when we need to, and that the floodwaters have some place to go or you're getting a hotel room.
So we talked about this a little bit already, or a lot already. 26 square miles. It's got a town, a village, well, 3 towns, a village. It's 16 miles from the Tivoli Bay to the headwaters. It's got a mix of forest, wetlands, farmland, developed, a little bit of developed as we know. Drinking water sources, both the town and the village, Bard College, and then all the little straws that come from people like me who live in the watershed and pump my water out of the ground. And it does have a history of flooding and flood damage along the main stem and some of the tributaries. This is the watershed, as you know. Let's get that one. This is the land cover. A little more kind of colors to what we were talking about earlier. What we can learn from or build on is that within the 100-year floodplain, which, caveat, the 100-year floodplain is not mapped for the entire length of the stream, so kind of 199 downstream has been mapped for floodplain. And within that 100-year floodplain, it's 13% developed, about 19% hay and pasture, and 65% forest shrublands and wetlands, which is still pretty good numbers when you're talking about impacts on a waterway. Okay, so as Carolyn said, the firm I worked for won a grant to study the flooding on the Sawkill. Kind of the objectives of the study were to assess what's the vulnerabilities within the watershed, and then provide some mitigation solutions, both kind of hard engineered things, bridges, roadways, those sorts of things, and then natural system solutions, whether that be land use kind of policies, preservation, green infrastructure, those sorts of things, kind of the softer sides. It was funded by NUIPIC and the Hudson River Estuary Program, and because there's a plethora of studies that go on in the Sawkill, we have a lot to work with and to build from with this project. Some of which being the FEMA flood study, which is old but there. The culverts and barriers study that was done by Soil and Water in Cornell. There was a kind of a project that built off of that culvert study that kind of prioritized the top 10 problematic culverts that the town took on with the town's engineer. There was also a concurrent study going on about climate change by a firm called ABET. And then we, in the town of Red Hook, have a community preservation plan and habitat resiliency plan. So that was another thing we tapped on this. We finished in 2018. We started in April of 2017. We had a stakeholder group of residents and people from Bard and the town and the village, Mylan, everybody who wanted to be at the table was welcome to be at the table and participate in the process. So that's where we got a lot of good information about mostly the historical flooding and what really happens when it rains. Okay, so these were the areas of the watershed where there were problems. These were either identified by the flood study anecdotally or through the hazard mitigation plan that was prepared, that it's held by the county but probably prepared a lot to do with information from the town. So as you can see, the call outs, it's throughout the watershed where you have problems. A lot of them, as you would expect, downstream, but places in Mylan are not immune from getting flooding as well. So there's places like the Annandale Road, Aspinwall Bridges, Mill Road, Linden Avenue, people like me, and Echo Valley Road, and goes up from there. You won't be able to read this, but it's in the report. This is kind of like a breakdown of those different problematic places and how we found out about them. You ask any highway super and they know off the top of their head where they have flooding and when they'll have flooding. If you ever want to know, they know when they have to put the cones up. Okay. One of the things that Fuss and O'Neill did was they did a HEC-RAS modeling of the existing and future conditions to find out Okay, where are we having those overtops? How are our structures doing in flooding situations? The answer is not great, but it's going to get worse, unfortunately. There was overtopping in sometimes the 10-year storm, definitely in the 50-year storm, and I won't get into 10 and 50-year storms, but that would be another discussion for another time, but we'll just call them that for now. Schaefer House, Bard College intake, the well fields, the Annandale Triangle, the Annandale Dam, Aspinwall Bridges, River Road Bridge, and Echo Valley Road Bridge. So those are the ones that are in trouble already. Cedar Lane, 21 Cedar Lane is right around Bard College. It's a private residence. They're already inundated with water in our flood study and our flood modeling. And even if bridges are not overtopped, they're going to be receiving flows that could be damaging them. Scouring underneath, scouring around, flooding roads. I mean, if there's a bridge there, it's going to back up the water. You know, there's only so much water you can pass under a bridge, and as you can imagine, if the force of water is going to make its own way when it needs to. It's going to route out the bridge, it's going to go over the bridge, and that's just not what you want to happen. It's just going to lead to damage. So in those future climate change situations, we've plugged in some numbers to say, okay, what's the worst case scenario? We hear all these different things about what climate change will do. Let's pick something that's pretty big, but reasonable, and figure what's the worst case. And as you can imagine, things did get worse. And the same structures as I mentioned before are obviously going to overtop in an increasing situation. But we had additional problems on Linden Ave, that bridge, which was actually just rebuilt not too long ago. The 199 bridge, which is down further on 199 from here, and the Echo Valley Road Bridge now would flood on the 10-year storm, where before it was, I believe, in the 50-year storm. Not to be dissuaded, there are things that can be done to kind of mitigate those increases. So we can do a lot of repair and conservation and restoration to help limit the increases over time and reduce the damage. So what are some of those things we can do? We thought about 3 different things: site-specific, targeted, and watershed-based mitigation things. These are the site-specific is obviously site-specific. So number 1, these are in no particular order. Sorry, Lori. Remove the Annandale Dam. Because it does cause a lot of flooding. If you remove the Annandale Dam, it will decrease flood levels upstream of the dam. If you remove it, obviously you have to mitigate the additional flooding downstream, but that can be dealt with mitigation and making more flood plain down below. And like I said, in no particular order. Replace the 9G bridge with a longer span. Right now, that 9G bridge is a pinch point. Okay, so if you know that poor property owner just upstream of it, they turn into a bit of an island when it really rains. So that's a problem we know about. So if you replace that bridge, you decrease the levels upstream of the bridge, i.e. that property owner and the West Bard Road neighborhood, which also turns into a bit of a moated situation when it rains. Obviously, or maybe not so obviously, if you did 1 and 2 together, you kind of have a bigger effect on those upstream areas. They work together to combine for a better product. Okay, replace the downstream Aspinwall Bridge and elevate the road there. Another pinch point, known problem. They've had to repair this bridge a ton. So if you can see, what we propose is that you kind of put the bridge level up where those yellow lines are. And that's, it's a pretty significant difference, but that bridge was put in the floodplain. I mean, it's in the floodplain. It's nowhere near being out of the floodplain. So if you want water to pass through it, you have to get over the floodplain so you allow the water to move. We also propose removing or modifying the Mill Road Dam, which is a dam just upstream of kind of this point here in Aspinwall, which has had flooding in the past, damage in Irene. They know there's a problem, privately owned. It has some hiccups along with it, but another thing we propose. Another thing is to expand the riparian buffer and increase the flooding floodplain area upstream of this Mill Road Dam. We're moving upstream, actually, it is in a particular order, it's from the bottom of the stream up, so, just happened, Lori, that you were at the bottom. So in this, we have the Greg Farm, which is a nice big farm field area. A lot of it's not farmed, some of it is. If we can talk Greg into preserving this area and turning it into floodplain, that would really give some storage during those flood events and reduce flooding in other places. Downstream of the Mill Road Dam, there were historic meanders that were, during our site visits, we found them through the woods. And to reinstate those, reconnect those, you would actually slow down the water, allow it to seep in, do all the things that natural streams do that are so great, and reduce some flooding. So it's just making it back into its natural natural state. There was obviously someone who went in and straightened it in some point in history. Replace the US 9 bridge with a longer span. Again, it's placed into the floodplain, so it's causing a pinch point and it's blocking. It's also in terrible shape, so hopefully it's on the list for the state to replace at some point, and when they do, hopefully they lift it up a little bit. There's also a failed dam in Battenfield Road that I think might be getting taken care of this summer by the Hudson River Estuary Program, and I think they have an AmeriCorps crew that may go out there and take that out. So it was just something we found when we were doing our field visit that can easily be taken out and then stream reconnected. Last two, replace and realign Echo Valley Road Bridge. I know it's controversial, but as far as the stream health goes, that bridge is kind of placed in the wrong direction. So if we correct it so it's along the stream the right way, you won't have such a pinch point. Right now it hangs a really hard left to hang a really hard right, and that's just not how streams work. In doing that, reconstructing the stream channel upstream of it would also help with stabilizing the bed and bank and providing more storage. Targeted recommendations, again, this is more like watershed-wide stuff that we can work on, is getting at these culvert upgrades that need to happen. We have the studies that show that these culverts are undersized. As we can do it, we should think about upgrading those into larger sizes. We already have our top 10 list, so start ticking away at those. Floodplain restoration and reconnection as much as we can, where we can, try and start instituting a project to add more benching, add more wood additions, again, spread it out, slow it down, seep it in the floodplains. So making it more of an active floodplain instead of channelized flow, that just gets it out quick. We made a little fancy map in our study that showed some possible areas to focus on for this repairing and restoration. Again, it's in the study if you want to look at that. And we are really lucky, there's a whole lot of land conservation in this watershed, a lot more than most. Right now, in the 100-year floodplain, again, lower half, not the whole thing, we have 28% of the land protected through land trust, so that's huge. So there's still more things that can be done, and we propose this kind of figure to show like where future kind of protection actions could be taken to have increased protection value on the floodplains. So doing a great job, you can always do more. Isn't that the way with environmental work? And then the watershed-wide recommendations that don't have kind of any sort of geographic target on them would be to look at land use regulations, protect the floodplains and the floodways, remove those artificial barriers and restrict them from going in there. So any future kind of those permanent structures, get them out of the guest room. Okay, if there's a way to get them out of the floodplain, do it, or site them elsewhere. Restrict your vulnerable development types to higher ground. We know it's going to flood. We know the flooding is going to get worse. Climate change is real. So don't put those vulnerable things in your floodways. You know, if you're going to put a generator for a whole community, don't put it in the floodplain. Stream crossing design standards would be nice, so you don't have those bridges that are in the floodway. And then protect those unfortunate properties that have been placed in the floodway to try and prevent or mitigate damages that are going to happen when they flood. So, I think I may have made it. If you want a copy of the report, I I'd go to that website soon, because I'm not sure how much longer it's going to be up there. I can work my magic and get it back up there, but it'll be a different URL and there'll be a remote removal. So if you want this study, that's where you get it.
Thank
And
you.
I think Robert has questions.
So do we have any questions for Jen? We take a couple.
So with all of these proposed plans that you talked about, what kind of resistance do you expect to encounter when trying to initiate these?
From which party?
Just, you know, what barriers?
There's always some sort of resistance to change, right?
Mhm.
In the case of the bridge that's right down the road from my house, the Echo Valley Bridge, people don't want to change it because it slows down traffic, because it's this weird jug handle thing. It's sort of a mortal game of Frogger going on, but it does slow down traffic, which is, you know, a good thing. So there's those sorts of problems. And then I could see with the Aspinwall Bridge, where the bridge should be, is gonna look really awkward compared to how it is now, you know, where you go down the hill over the little bridge, and, you know, it's going to be a larger bridge that's spanned up high, so it's just visually going to be different, and again, people don't like change.
So funding's not an issue?
Oh, well, yeah. That, you know, yes, that's always an issue. But if you're talking about angry neighbors, those are the other ones, but yeah, funding is always an issue. But bridges have to be replaced eventually, so like in the case of the Route 9 bridge, where the state has to replace it because they know it's falling apart, maybe you could nudge them to bump it up a few feet, and it won't cost all that much more when they know they need to replace it. So it's that failing infrastructure trying to get things improved thing.
You said the Annandale Dam was backing up water into Linden Acres area. Where?
Not into West Bar, that bar, yeah.
And I think you also implied that the Mill Pond, the Mill Road Dam was backing water up.
It will
Where?
It will back water up into like the Gregg Farm area. Granted, it's not terribly, I mean, it's the back of the schools. So it's not causing damage. I mean, the River Road Bridge is flooding. So that's where there's a disruption in traffic flow, but there's not properties upstream. I mean, their other problem is that the dam is failed in large storms, so there's a bit of a fundamental problem there.
Because after those long rainstorms we had a couple of weeks ago, I live on the Mill Pond, on a sort of backwater off of Linden Avenue. And the water was flowing into my little backwater so fast that it was making ripples. So that sort of indicated to me that that dam was holding some water from flooding downstream of it.
Well, yes, it will, but that's backwatering. That's you know.
And there's room for it to backwater there.
On your side, but again, it's gonna increase its height, and eventually it will flow over the River Road, not River Road, Mill Road Dam.
Mill Road, yeah.
So.
Yeah, that's a very narrow pinch point under that bridge, yeah.
So, I mean, there's a few things going on there beyond holding back water, which can be a good thing, and although I won't get into it, I'll talk to you about it later. I mean, it's what comes in goes out, so it's holding it back to a point, but then once it reaches a point, any water that comes into that area is flowing over top the dam. Okay, kind of that overfilling a bathtub thing. There's a point where it just is coming into your bathroom, and it's just coming at the same rate. There's nothing holding it back.
Get the baby out at that point.
Yeah.
First, it seems like such an important study to have such a beautiful URL, but is there another place that could host it, like the Sawkill community site, so that it exists in perpetuity, more easily
It was paid for by the
accessible?
Hudson River Estuary Program, so if somebody wants to download it and put it on there, yeah,
And
we can definitely do
then,
that.
sort of related, like, is there there's all these really specific projects identified. Is there an implementation plan, or is it in the hands of those who will implement it, or how is that? Can you talk about where it goes?
We left the report that we gave kind of a Chinese menu of things that you could do, and we gave possible funding sources to go after to do those, but then that was the end of our project scope. So it's then somebody has to pick up the football and run with it.
And has anyone, or is anyone picking up that football, I guess? Is that the question?
I do not know.
We're taking notes, I guess.
All right, so our final presentation for the evening is from Dan Shapley. As Director of Riverkeeper's Water Quality Program, Dan Shapley organizes a large community science project with dozens of individual and volunteers and organizational partners that include Bard Water Lab and the Sawkill watershed community to sample more than 400 locations in the Hudson River estuary and many of its tributaries. Riverkeeper advocates for water infrastructure investments, watershed management, and drinking source water protection based on this data and the people who gather it. Dan is also a founding board member of the Sawkill River Watershed Alliance and a board member of the Hudson River Watershed Alliance, and then also serves on the Joint Environmental Committee for both the village and the town of Rhinebeck. So,
Thanks.
oh, and Dan is going to be presenting on and then leading a discussion on next steps for the community to protect drinking water at its source.
Yes, and I should mention Kate's a member of the Hudson River Watershed Alliance too, so we are representing. Thank you very much for having me. I'll try and keep it quick and loud so that we're energized as we go into the questions. And thanks Eli for covering the poop. It's nice, it's often my role, so it's nice to get to talk about something else. It's a presentation, it's a little maybe more storytelling than data, so hopefully it'll be of interest here. So key points I'll try and get, make as we go through, but source water protection is basically, across the board, the idea is to be a cost-effective, proactive way to protect high-quality public drinking water supplies. As you've already heard, the Sawkill and its watershed are sources of drinking water for the community. Also, the Sawkill is connected to a larger drinking water supply, which is the Hudson River, and I'll talk about that a little bit. Third, that communities like this and elected community leaders with the community of agencies and nonprofits really have have to be in the driver's seat, to maybe say that even more strongly, and it's written here, to protect public drinking water supplies. It's really on us to do. And that we do have a tool, Riverkeeper has a tool I'll talk about a little bit that can help, and Karen and I have been working on it a little bit. Just quickly about Riverkeeper, we started with this pipe when things were a lot worse on the Hudson. This was an oil discharge pipe in the mouth of the Croton River, and when 52 years ago, a group of ex-Marines and fishermen and other gnarly types got together in a room and were like, sick of this kind of thing, and they found a way to do something about it, and basically that was a law that hadn't really been used very much. It was written in the 1800s. They dusted it off, started going after polluters like this with some success, and stopping discharges like this. And enforcing environmental laws, it's still part of what Riverkeeper does. We also have a boat on the water. Captain John Lipscomb today, I think, reached the Capital District on his first patrol of the season. So he left New York Harbor 5 days ago, got to the Capital District today, takes samples along the way. He's the eyes and the ears and the voice for the water while he's out there. He also patrols all the way out on the Mohawk River, so that, I think Karen showed that big watershed map that showed, this huge quarter of the state of New York essentially is the Hudson River watershed, so he goes all the way out on the Mohawk, all the way up to Fort Edward. And then the third part is the community science that, and I have to pause here, we're always really proud of ourselves for what we do with citizen science, community science, but I think what the Sawkill community has done with this, starting with the community to ask the questions and then looking for ways that the scientists can answer those questions, and then the community helping to gather the data to answer those questions. It's the model that we all need to, I think, aim for with all of these projects. And it's just fantastic. I'm humbled to be here presenting to you and trying to help, this last conversation, because I really admire this work very, very much. Again, so source water protection is really just, source waters is the term of art for drinking water supplies that rely on water, which all of them do. So whether it's groundwater or a lake or a river, that's your source water, and the watershed around it that feeds into it. And then protection is just a watershed-based strategy. So it's all those things that we've been kind of touching on throughout these talks, protecting the natural filters as much as possible that naturally keep the water clean, keep nutrients out, keep salt out, or excess nutrients, I should say. Those are the strategies. We sort of know the gold standard for doing this. It's right in our backyard. New York City's drinking water supply is the best protected in the world. It's what everyone turns to as the example of how you protect high quality drinking water at its source. And just to underscore sort of the cost benefit writ large for a drinking water supply like this, New York's going to invest $720 million over the next 10 years in protecting stream buffers and land conservation, upgrading septic systems, things like that, which sounds like a huge investment, and it is, but it compares to the cost of filtering water, which is probably $11 billion over that same time period if they were to fail at protecting high-quality drinking water at source and have to filter the water. So again, it's proactive, it protects the environment, it does all the things we like for watersheds, and it saves treatment costs in the end. So the question that we've been asking is that if half of people drink New York City water, which in our state is the case, what about the rest of us? What about the other half? And this is just to illustrate, this is Newburgh's drinking water supply. This is the Washington Lake, an aerial view of it. And Washington Lake sits on outside of the bounds of Newburgh, city of Newburgh. It's in the neighboring two towns, New Windsor and Newburgh, town of Newburgh. And the crisis that you probably heard about, and I think I've talked about at a previous one, so this is very quick, is there's firefighting foam used at the Air National Guard base. That was spilled. It contaminated the stormwater system and then the streams that feed into the reservoir, which then led to a crisis, a public health crisis, people wondering what the exposure of that drinking water over a long period of time is doing to their health. And then a huge investment of our resources. So the state's invested at least $50 million so far, and with hoping to recoup that from the federal government, but we'll see. So what we did was we studied that problem in Newburgh and what happened, and developed this scorecard, which Karen mentioned. And it's meant to help communities look at their own public drinking water supplies and sort of identify gaps and opportunities for better protection. And we're thinking of it as sort of a gateway drug for source water protection, because it's not going to get you, a final plan or a huge, flood mitigation study with specific projects, but it gets sort of orients and gets us on the road to that. It covers some basic elements. The source water assessment is this really important tool that came out of the Safe Drinking Water Act, where Congress said, whoa, we need to protect, we really pay attention to drinking water sources special, not just the way we pay attention to all waters, but really especially for public drinking water supplies. And they asked the states to look at every public drinking water supply and come up with an assessment that would say, what are the risks to this particular supply? How could contaminants get into it? Is it very, very vulnerable? Is it not? And so New York did these back in the early 2000s. And one of the things that we've found, and I think Karen's run into in the work looking into this, is that they're very hard to find. Like, they're hard for people like us to get our hands on so that we can then act on them. It's hard for communities or community groups or even those empowered by their local officials sometimes to get their hands on them. So they haven't, which is a long way of saying they're not being used to protect drinking water. They were done, but they're sort of sitting out there and not particularly well used, at least at the community level. So again, the scorecard kind of helps to assess some of these elements to ask the question, are we more like New York City or more like Newburgh? And which isn't to say, is our water contaminated or is it poor today, but is it vulnerable or is it well protected with kind of a multi-barrier approach of different practices. So the next step we did was kind of look at some of our big surface water supplies, who's relying on the most some of these drinking waters in our region, in our watershed, and then realizing that the Hudson River itself is one of the big areas, and we're Riverkeeper, so we wanted to focus there. And these are the five drinking water intakes, 7 communities overall that benefit or that use the Hudson River, including our neighbors to the south, Rhinebeck, and I live in the town of Rhinebeck. I'm in the great white void, just down. I drive into your watershed, to the Sawkill, to dump my trash at the transfer station. But they cart it away. It's not that going. It's okay. We play in the ball fields. This is I'm still learning to use Google Maps, but it's like tipped on its edge, the Hudson River south looking north, and those are the 5 communities that have water intakes into the Hudson. These are some of the tributaries that reach the river in that stretch that best we can tell are sort of by the Department of Health's definition of the relevant part of the Hudson watershed are relevant, and that's the watershed area that would be feeding those streams. And you can see the Sawkill. Everyone can recognize which one's the Sawkill? Yeah. And here, just a coarse look at some of the public drinking water supplies in the Sawkill, and I think the village wells were mentioned earlier, but the town has well also. So there's town public wells for the town, and the village with separate well fields. Bard College itself, as we heard, is directly from the creek. Then there are other smaller ones that don't forget about, like Trailer Park, I think, probably has a private well that serves that community, and that's probably a decent number of population. Are the public schools in the Sawkill watershed or Stony?
Yeah, they're in the Sawkill.
They're in the Sawkill, so those have their own wells, presumably. Those are important. Thinking about the home, I forget what it's called, the Red Hook Home for Juvenile. What is it?
Parker Center?
Yeah, up on the hill, so that's got its own water. So there's population centers that aren't your major, public water supplies that are also worth thinking about. And then, of course, all the private wells. So I'm gonna go quickly because I want to leave time. We set goals for our Hudson River drinking water project, and I put these up because I think they're common to a lot of protection programs or what you might want to do. But organize those people who are reliant on the same resource first, because they have the same interest, and then try and zoom, widen the lens to anyone who might be influencing those water supplies if it's different municipalities. In the case of the Hudson water supply, they really wanted a unified voice because they were concerned about crude oil transport on the river. So that was one thing that gave them more power and more authority in their voice by speaking together. And then I'll skip over some of these. Just to get to some of the findings from our initial report, which again I think are going to be very common to a lot of water support sources, is there aren't really good source water protection programs in most places. So you can expect that's probably a gap here, and I think it is. So the source water assessments are out of date because they were done quite a while ago. They relied on 25-year-old land use data. So some things have certainly changed in that time. We have generally been addressing water quality issues by upgrading treatment rather than looking at the source water quality. So when you look at, like Stuart was saying, the nutrients causing disinfection byproducts in a treatment process, that's a big one. Harmful algal blooms are emerging as a really big one. And then watershed planning efforts, at least to date, have not really focused on that endpoint of drinking water. They've looked at a lot of other really worthwhile things, but that hasn't generally been a focus. So that's shifting, and maybe here is one of the examples. And then intermunicipal efforts and funding for them are lacking in many cases. And these are the recommendations, and they follow right on those findings essentially. So these are lacking, try and start to fill in those gaps, and these are some of the big ones. This is the crew. This is the raw water intake at Poughkeepsie, big pipe sucking out of the Hudson. And they are, actually, as of this week, have all agreed to sign an intermunicipal agreement to work together on source water protection. So they'll be signing that next month, or later this month, which is exciting. Even more exciting, they came up with a great name, the Hudson Seven. And like, I'm the writer, and they came up with it, so I love it.
Is Brad Pitt's story?
Yeah, I know, right? It sounds like they're gonna rob a bank. So that brings us to our kind of group discussion, and I'm gonna do my best to facilitate this in the spirit of how you all started to come up with your questions and what you wanted to focus on. I put up a couple of ideas kind of specific to source water protection that I'll touch on while the note takers set up. But you know, looking to update those source water assessments and create a source water protection plan. And these can be done on a town-wide basis. New York Rural Water does these actually for free. There's a long list to get on their list, but I'm pretty sure it's a free service, and as a relatively small community, the Red Hook, I think, would qualify for that. So there's a potential way to do that rather affordably. DEC also, I know you're already working with Elisa, I think, on doing that, her new evaluation that she's created for the Hudson River Estuary Program, so that's going to be powerful and really valuable. I thought I was going to tell you about this great new stream buffer tool that has been created, but it sounds like you're already using it. Because you mentioned it in your slide, Karen.
Well, that's to say, went to the webinar.
Okay, great. So you can start using that. So this is this great tool that it comes up with a health index for a sub-watershed area, you know, your whole watershed or little pieces of it. Comes up with some of the major threats based on available data and gives you, kind of points you in a path that you can ground truth to decide, okay, these maybe with the buffer recommendations from the flooding study, build that out to say where do we need more buffers, and then apply your tree for trip sort of effort in those directions. I want to mention naming streams that are unnamed, I think is a great community outreach tool. The town of Rochester and the Rondout Creek is doing this, and they actually tied it to a new law that they passed, and I forget exactly what, but they, basically in their code, there was a requirement to protect a certain buffer if it was a named stream, and then a lesser buffer if it wasn't. So they said, great, name the streams. So they're going around and naming the streams. So I don't know what the codes are here, if there's any parallel, but even if there isn't, you know, there's that beautiful stream that runs down Norton, the beautiful stream that runs down the other road that goes in that direction, and they don't have names as far as I know, and I would imagine it would be a great way to get neighborhoods, you know, the Bob Wills
I can think of a lot of
method.
ways to have some fun with that.
Yeah, so I just keep
But I mean,
picturing
well,
this because I think it'd be fun.
If it's unnamed, also if it's unmapped,
Right.
right, it's unprotected.
Yeah, and it's not in people's minds,
Yeah.
right? If it's got a name, then it's sort of, like, you know, you name your pet, you don't just let it run around.
Kids, pets.
And another idea, I haven't seen, you know, like, I think a lot of that data that was presented on salt in East Fishkill is because there's a well testing law, right? So there's data that is required whenever a piece of real estate transfers. There has to be more extensive testing than the bank typically requires. So that allowed, you know, for all those findings, valuable information. So that's one option, is to think about, you know, local law, or I imagine that a buying group, you know, like you could probably get a cheaper price at Smith Labs if you said, me and my 20 best friends are all want a well test right now, or we all want to, you know, get our septic tanks inspected so we could go to the septic supplier and get some quotes. So I feel like this kind of community where you're so kind of tight-knit and relatively small area could probably experiment with things like this and maybe get some of those septics looked at and some more wells tested. So I'll quiet down now and let everyone else.
So one thing is that Michelle took some notes as questions came in after each presentation on some of the issues and concerns that people were bringing up with those questions. And then it's just part of this discussion, we just wanna keep track of all the great things that you bring up. So any additional issues or possible solutions to some issues and next steps, we're just gonna be trying to keep tabs up during this conversation.
Now is the time to talk. What about issues? What other issues that have not come up yet, maybe, or not reflected here, are on people's minds as concerns after seeing some of these presentations?
Or just from your experience living and working in the watershed?
What if we tried, like, raise your hand if you agree, if you share a concern about Nestle water. That's a high interest, high issue. What about septics generally, and particularly in the village?
That's kind of a self-limiting problem though, isn't it?
Hmm?
Been putting in the sewer system, so.
Should be dealt with.
Yeah.
Well, no,
That's
actually.
is that a
Well, I guess it's only part of it.
No, I mean, it is important, but it's also, it's in progress to be fixed.
Well, okay, so the important thing is that they will be connecting, the new sewer system will be made in such a way that it will be connected to the ends of the septic systems, the septic tanks. So the old septic tanks will still be there and not replaced. So if you have leakage and you have a ruptured septic tank, you're not really solving that problem.
Right.
So that's still an issue, and people should be aware of that one.
Lawn fertilizer, is that of high concern, high interest? So maybe a little less. Is this helpful to gauge what people's general water softener? What about salt more generally? Road salt? Is that on here? I guess it was an overriding, we already knew. And then climate change impacts. That's gotta be biggie. What is this? Resistance?
Resistance to the recommendations, the question. From,
Well, that's a good one.
Pull that out.
Yeah. You are concerned, or you
Yeah,
have a
no,
question?
it's just something to bring up. Was just like I was in a water quality testing class last semester, and we saw some algal blooms at the right above the Annandale Dam, and you know, as climate change continues to you know, sort of make our systems more volatile, increase water temperature. We're going to have more issues with harmful algal blooms, which are a risk to our drinking water sources.
Yeah.
So that's something to, and with this high nutrient concentration that is, we saw the nitrates are going up since the 70s. It's something that everybody should.
And those blooms were right in the Annandale Dam's the one you cross on as you're
right
heading
above
into
that.
Barn campus, right?
Yeah.
So the same one that has a flood risk.
Well, they both
One
have
of-
flood risk, yes, they all
One
do.
of the particular
Yeah.
projects. Also where a micro hydro project
Yeah.
is
Yep.
proposed. Should we move on to solutions?
Yeah, that one, yeah.
Oh,
I guess like jumping to the protection initiatives, I think something along with maybe naming streams that I've been thinking about recently is a lot of like knowing the access points to the Sawkill, because there's the Sawkill mostly runs through a lot of people's backyards, but there are public access points to the Sawkill, and so maybe like celebrating those areas, or just even getting more, like in the rec park, it's kind of tucked away in that field. If you don't know it's there, then how would you visit it? Or why would you visit it? So maybe thinking about those access points.
that's a great idea. the Sawkill River is doing a water trail. It's more paddleable, so it's a lot, you know, makes sense as a trail concept, but I think that's a great idea.
Yeah, adding on to Tierney's point, I'm from a city and we have an urban watershed, and like they have at every access point they have like a little sign there that says like where the other access points are and like how you can get involved and stuff like that, and like just like a lot of publicity, I'd say, and like public face. I don't know. I mean, I'm like a Bard student, so I don't know the situation of the Sawkill to like the entire municipality. Like who knows about the Sawkill watershed community, everything.
Yeah.
Well, there aren't that many access points to it, right? Because so much of it's on private property.
Are all the sampling points at public access points
They're
or
at culverts.
with permission?
Yeah.
Yeah.
Yeah, so, like, there's two on 199 right next to each other almost, hanging over the culvert.
I have a dream that we can get the folks that are putting together the Red Hook Commons, the new treatment plant, together with the really nice guys who run the Bard waste treatment plant. Because if we're seeing, you know, nutrients coming through, which to be clear, those aren't regulated. If you are going to try to deal with the nutrients coming out of treatment plants, you're taking an extra step that often doesn't get the funding that you need to be able to do it. It's something you do on top. But I would be interested to see if there's a way we could think creatively between these two waste treatment plants to start working on a solution over the long term that could reduce whatever's coming through from them.
And also, if investments in treatment technology are part of it, if there is a collaboration, I don't know if Bard College would qualify as a municipal applicant, but there's a new category of grants for intermunicipal cooperative grants on water infrastructure. So you can get more money, it pays for a higher percentage of the cost of the project, and so working at a watershed scale on infrastructure projects where there's multiple plants or projects, and it could be a combo of drinking water and wastewater, so you know, there could be a way to collaborate and also, you know, get more money to help.
Well, I'll say as the local official here, what would be great is to have a series of recommendations that relate to the issues that you articulated here. I noticed in the long list, we only so far have recommendations from our flood risk assessment, and that just ended a couple months ago. And so we'll be taking those up, I think, within the next 10 months or so for the next round of funding. There's some really interesting options there that I think would benefit us on so many levels. With the bottling, I recommended a moratorium last year, which is in place, on all harvesting, water, timber, soils, and so on and so forth. You know, all natural resources with the exception of sun. We don't want to that harvesting here. And so hopefully that subcommittee will continue to work and make recommendations with your assistance. But as I look down this list, it'd be great to have, you know, 2, 3, 4, 5 recommendations about things that we can implement now based upon best practices in other similar situations to consider. I'm sort of eager to get some of these things in place.
That's a great
Do you want to just take that piece of
Not
paper?
every town in the Hudson Valley region, I will say, has such invitations to watershed-based groups to offer their ideas. So that's a really welcome and important offer.
I like the idea of using scorecards a little more in two ways. Once we complete the scorecard that we're working on now, and we'll have an idea where the gaps in protection are, I think that can be used as a basis for some next steps and a way to measure what kind of progress we're making in those next steps. You know, identify some of those and pursue them. And along with that, I know this type of scorecard is more controversial, But I like to look at the idea of making a second kind of scorecard than for the Sawkill that's more like what they do on the Chesapeake Bay, which picks a number of items that are vulnerable points or indicators that you track and measure. Maybe there's only going to be maybe 3 of them, maybe 6 of them, depends on your water source. But you look at those and you measure your progress on how much improvement you're seeing in those things. It can be a water pollutant, it can be a fish or a plant, it can be, all kinds of things depending on, what the indicators are for the body of water you're looking at. And I think that's another way to kind of focus action so that you're not just kind of scattered, or you have a study here and a study there and you're not sure how it goes together, but you're focusing your action and you're able to measure and track your progress. It's not simple to do, but I think it would be an interesting challenge.
Any last good ideas?
Last minute ideas? I mean, there's plenty of other solutions, and what we can do is we'll summarize some of the issues and some of the stuff that came up, and we can think about it as a leadership team, but also bring it up again at future watershed meetings to continue the discussion on these topics and what we learned from tonight and how we can possibly come up with some recommendations and potential solutions. And those will also change as the Sawkill watershed community continues to collect even more data moving forward. And so we'll keep you all up to date on that, and hope this encourages you to attend future meetings to stay up to date on these topics and contribute your voice to these topics as we help move them forward. But before we leave, I would like to thank once again on behalf of the Sawkill watershed community all of our presenters for this evening. They did a fantastic job. And we really I'd like to thank all of the folks that came to share information about the Sawkill watershed during our refreshments this earlier in the evening, so that folks could come and talk a little bit more and learn about some of the projects. So thank you. Thank you to all of you for taking your time out this evening to come learn more about our watershed and what this community is working on. And thank you for many of you for investing your time and helping collect this data and this information and continuing the conversation. And finally, thank you once again to the leadership team for planning and organizing this event. And we appreciate your attendance, and we hope to see you at future meetings. And if you have questions...
Wait, don't go yet, because I want a special round for Carolyn, who has gone above and beyond in putting this together. And we just got it in just in time, didn't we? Yes.
I didn't have a baby while I was here, so woo! That's my biggest fear. But thank you, we really appreciate it. Help yourself to refreshments as you leave. If you have any questions, feel free to approach any of the leadership team members. And again, if you want to stay up to date on what we're doing, just make sure you're on our email list. Thank you.
Yeah.